All right, okay, let's see some reminders. You know where to find the notes on the lecture site. I just released the recording from Tuesday, so if you want to review the lecture, you can also do that. Your lab number 0 has been completed and also submitted. So please review them. I will also make the programming, the mock-up test materials available to you. Maybe later tomorrow, definitely over the weekend, so you can also take a look. And your programming test number 0 will be during your Enroll Lab session next Wednesday, September 24th. I already released the guide, so please take a look at about the coverage, format, grading scheme, expectation, everything, right? Everything has been explicitly specified there, okay? And then your lab number 1 has also been released. It's going to be covered by programming test number 1. Okay, so it's also happening at some point soon. So please also make sure you start it and then ask the TA, reach out to me, and we can help you. Right, it's due next Tuesday, I believe, right? So please make sure you actually get ahead with that. Any question about the course in general? Okay. So guys, let me say that one more time. If you do come to class, I'll really appreciate if you pay attention. If you really have to use your laptop, not for taking notes, but to do your own stuff, or use a mobile phone throughout the lecture, it's very disrespectful to me. So if you really don't mind, rather you do it outside. Okay? I don't mind if you skip my class. The recording is there. All right? I hope I don't need to call you out. Okay? I really appreciate that. Thank you. All right, so today, let me recap about what we covered from Tuesday, and then let's see what we covered on Tuesday. And then we'll continue with the exercise about arrays and reference aliasing, okay? Okay, so we spoke about variable shadowing. So we talked about 3 different versions about defining the constructor. Version number 1, if you choose the parameter name, for example, new weights, that does not clash with the attribute name. In that case, you don't have any problem of the variable shadowing. In that case, you can easily just say new weights is assigned to weights. And you can also see the Eclipse highlighting to actually show to you about which variable is being updated and which variable value is being used. So there'll be no confusion. Version 2 that we set was, when you actually get a little bit more advanced, usually more common practice would be for Java programmer, they will simply choose the name of the parameter just the same as the attribute name. So they will say weights over here, which kind of correspond to the weights. As soon as you have a clash between the parameter and also attribute name, so that means you got variable shadowing. What that means is, if you simply say weights on the left-hand side, it is going to be shadowed by this parameter rather than this weight right here. All right, so apparently, that's not the right logic, because when you actually want to do the constructor, this way here is really meant to refer to the attributes, not really the parameter. So the way to really get rid of, well, not really to get rid of, variable shadowing will always be there. But to really get through the variable shadowing, that'll be version number 3. You actually have to say this dot weights and also this dot heights. If you look at Eclipse highlighting, you will say that this weights here is going to refer to the weight attributes nicely, right? So these are the 3 versions that we spoke about last time. So which version you really choose, either version 1 or version 3, so it's completely up to you. So I would say you can just choose whatever weight that you really prefer. At this course, we don't really, we're not really picky. However, you just ought to know how each of the 3 versions work. I think that's the most important. All right, any question about variable shadowing? Okay. And then we talk about visualizing the objects. So we talk about you have some memory block specifically reserved for person objects. You got selective list of attributes you want to trace, and also you got instance specific values here for the attributes. And you got a reference variable here, Jim, and which stores the address of this particular objects. It is so crucial for you to know the following. Jim here only store the address of this particular object. Jim here does not store like a 50. It does not store like a British, the string. It does not. It only store the address of the object. And in turn, the object itself contains these values. So it's kind of indirect. So only the address value is being stored. And then we try to do tracing, using our diagram notation. So we kind of use, draw 2 boxes corresponding to the 2 new keywords right here. And when we try to do comparison like this, when we say Jim equals Jonathan, So there are two ways for you to interpret this. Number one, equal means Jim and Jonathan store the same address. In this case, apparently not, because you can see that Jonathan is storing the address of this object. Jim is storing the address of this object. These two are different objects, so there's no way the address will be the same. So the second interpretation is basically what I just mentioned. You can think about equals here simply means, diagrammatically, Jim and Jonathan point to the same objects. But is it the case? So you can see Jonathan and Jim, they actually point to different objects. So this equal here should be actually false. All right? So this kind of a comparison of the addresses, you want to really feel comfortable. That's something you want to be very comfortable with. Okay. And then we spoke about how you can trace method call. So whenever you got, for example, let's say accessor method call, you got Jim.getBMI, Jonathan.getBMI. When you step into the method call, method execution here, every occurrence of this keyword here will be replaced by either the context object Jim or context object Jonathan. So you're going to trace the values accordingly. That's something we did in detail. If you want to see the more detail about tracing, you can refer to the recording, or you can reach out to me. And we talk about basically copying of the values. So let's look at this line only. When I say J is assigned I, because J and I are both primitive values, what I'm saying is copy whatever that is stored in I, which is the 3 value here. And then copy that value into the variable J. I'm copying the 3 here into here. Right? I'm just making a copy. The way we do copying for reference type will be very similar, except we're copying addresses as opposed to integer value in this case, right? So let's look at this line only. When I declare P2 to be a reference variable that stores the address of point objects only, now I'm saying store the address that is stored in P1. P1 currently stored the address of this particular object. I want to store the same address into P2. Diagrammatically, after the variable assignments, P1 and P2 should really point to the same objects like this. All right? So that's the most critical comparison you want to make between copying primitive value and also reference value. Any question about this copying here? We're going to extend this notion a little bit further today about what if, let's say, one slot, one element in the array actually refer to an address. How do we copy values over or maybe copy values into it, right? Things like that. That's something we'll see today. All right, so this was the last exercise we did. So can I just show to you about tracing the for loop, right? Also, we talk about 2 different ways to initialize an array. So if you use this notation here, you know that the size of the array will be 3, exactly, right? You see explicitly the numeration of the elements in the array. And this one here, you actually got an array of certain size, and this should be some integer expression. So just figure out the value for the integer, and then you know how long the array should be. And if you use this notation here, that means initially, each element in the array is going to keep the default value. And in this case, it will be up to the for loop to really assign the value into each element one by one, right? That's something we traced last time. And one more thing to recap. Whenever you want to trace a for loop or while loop at this level, you should always ask yourself the following 2 questions. Number 1, how is the loop counter value going to change its value? In this case, 0, 1, 2. And we know that when I gets to 3, it's not going to lead to a 4th iteration because this Boolean condition here is going to evaluate to false, right? So that's question number 1 you want to ask yourself. Question number 2, accordingly, how many iterations do we need to trace? So since I value is going to be 0, 1, and 2, in that case, we got 3 iterations in total. So when I do the tracing, I got a very clear idea how many times I need to execute the same pattern, right? So the same pattern over here, except the I value will be replaced by either 0 or 1 or 2. So that's something we'll see again today. All right? Any question from Tuesday before I move on? All good? Okay. So what I want to do to begin with today is to go over some very similar pattern like this as an exercise. That's something I also ask you guys to try. If you get a chance to try, that's good. Otherwise, you can grab a piece of paper right now, or you can load the example, or just open out like a blank page on your tablet computer. So I think it would be nice for you to practice this together with me, okay, this exercise. So I'm referring to slide number 52, right? So we're going to execute this Java code here line by line. And let's now start with the following, okay? The first few lines will be something I want you to visualize right away. Now, what's going to be the diagram look like after executing line number 1 to line number 4? So we got 4 objects to be created. So let's make the following assumption. When you draw the box for the person, let's assume the relevant attributes are name and also age, only 2 attributes for this example here. All right, so why don't you visualize line number 1 to line number 4? I'll do that on my iPad and we'll compare. Okay, take a minute or so. Another thing you can also assume, so you can see the constructor person here only takes like Alan, Mark, Tom, and Jim, only the string value for the name. You can assume that maybe the age over there is going to leave as the default value, like a 0. We can assume that, okay? But in the actual test, this will be more explicit for you. Okay, I'm nearly done, so hopefully you're also at least on your halfway. Okay, just one more moment and we'll compare. Okay, so these 4 lines should be rather straightforward, right? Just draw, depending on how many new objects that will be created. All right, you should have something like this. Because, let's see this, we are talking about these 4 lines. So we got 1, 2, 3, and also 4. We got 4 lines over here, right? You can see we got 1, 2, 3, and 4. 4 new keywords, that means 4 boxes to create. And for this one here, new person, with Alan, and also default value is 0 for the age. And Alan will store its address, right? And similarly for all the other 4. So we got Alan, Mark, Tom, and Jim. Alan, Mark, Tom, and Jim. 4 boxes, 4 objects. That's how we start with. The next line, which we have seen something very similar. So we are basically creating an array called persons1 right here. And right away, you can see that what's going to be the length of the array? 1, 2, and 3. So length should be 3. Okay? And for this one here, I'm going to somehow write something that's slightly longer, but it's equivalent. So that'll be easier for you to see exactly what this line is going to do. Okay? So let's put this aside. Okay, I'll say it's a star. Okay? I'll put it right here. So this single line here can be split into 4 lines. Okay? The first line there is, first of all, to create the array objects. So we got person, array, and then let me say PS1, okay, just for short. And then we know that the length is going to be 1, 2, and 3. Will be new person array. And then I got length 3. And let's visualize that right away. Okay, so that one there is going to create the PS1. It is going to point to an array of length 3. And after this point, of course, we got 0, 1, and 2. And at this point, we have only created the array object, but for each individual slot, they haven't stored any valid address just yet. So let's explicitly denote null value. Okay, this will be null. This will be null. And this will be null. Okay, explicitly. Okay. And what about the rest of the 3 lines? So think about here, Alan 0, Mark 1, and Tom 2. Somehow the value that is stored in Alan is going to be stored in index 0. The value that is stored in Mark is also going to be stored in index 1, and etc. Okay? So how do we kind of express that in Java? It will be expressed like something like this. So we got basically PS1 at index 0. So this expression here refers to just this slot. Currently, it is storing null, but we want to replace it by something else. So we put on the right-hand side, right here, just Allen. Right, you can see PS1, 0, 0, and then Allen here. That's a correspondence. Okay, let me just finish the other two lines, and then we'll try to look a little bit more closely about exactly what it is going to do, and also change the diagram. So similarly, for index 1, so we got PS1, index 1, Mark. Okay, and also we got another one, PS1 at index 2, right, Tom. So this single line here is equivalent to 1, 2, 3, and 4. Let's look at how about this one specifically. Okay, and for this one here, let me just say one more thing. Okay, I'll write it down aside for you. Okay, just to be 100% clear. So let me say this is star star. Copy the address store in Allen into the left-hand side, index 0 of array PS1. All right, let me repeat once more, and then the other two lines will be done in a very similar way. So copy the address stored in Allen. Copy the address stored in Allen. Copy that into the index 0 of PS1. Okay, what does that correspond to? So you can see copy the address that's stored in Allen, which is referred to these objects. Once we store this object's address into index 0, so rather than pointing to null, it's now going to point to the same objects that Allen is pointing to. Agree? Okay. So that one there is actually say, rather than pointing to null, it's actually going to point to Allen. And the other two lines will be done in a very similar way. So now copy whatever Mark is storing, which is the address of these objects. Copy the address into index 1, which is right here. So after this copy, index 1 is going to point to wherever Mark is pointing to. Like that. So rather than pointing to here, it's going to point to right here. Okay. Let me just move Mark to right here. Okay. All right, the last one here, which is right here. Okay, PS1, 2, which is this slot here. And it's going to store the same address as what Tom is storing, which is this object. So after that, rather than pointing to null, it's going to point to wherever Tom is pointing to. All right, so we got 1, 2, 3, and 4. So when you redo this exercise here, you just want to convince yourself that this line here is really equivalent to 1, 2, 3, and 4. Of course, when you actually try to do your lab or maybe programming test, whenever you want to somehow initialize an array, you can try either way, okay? As long as you know what you're doing. All right, next line. We create another persons 2 array. And the type is also a person array right here. Okay, let's see how we can visualize it. So that one there, we got, okay, this line here, orange. Okay, it's going to be created as an array of size, this value. So persons 1 refer to this array. Its length is 1, 2, and 3. So this part over here is going to be 3. So we're creating an array that's equally long as PS1. So let's visualize that right away. And this notation, we know that every element in the array is going to keep the default value. In this case, it's going to be the default value for person, because we know every element in the array is going to store the address of a person object. So default value should be null. So we got PS2 pointing to an array of size, also 3. And then I'll say 0, 1, and 2. And in the beginning, we got null, null, null. Question so far? Yes? Persons. Yeah. I could have written person, but when you trace, as long as you know what you're doing, you can shorten the name just to be more efficient, right? So PS1, persons 1, PS2, persons 2. Yeah. All right, so let's now trace the next few lines, just about the execution of the for loop. And since we already did that earlier exercise on Tuesday, so we pretty much know what's going to happen at a big picture about this loop. We know there'll be 3 iterations in total, right? Again, you got to remind yourself, persons 1 dot length will be 3. So I value will be 0, 1, and 2. So I'm just going to trace it right here. Okay, I'll say star, star, star. Okay, we'll put it right here. Put it aside. Okay, so the I value is going to be 0, 1, and 2. Okay, and then we're going to basically use this same pattern over here, but every iteration is going to use different I value. 0 for the first iteration, 1 for the second iteration, and etc. Okay? Let's just copy exactly what's going to happen for each iteration, and then we'll try to see what's going to happen. For iteration 1, when I is equal to 0, so we got persons 2 at index 0 is assigned persons 1 at index 0. Right? You can see we replace I here just by 0. Iteration number 2. We actually got the same pattern, PS2, but at index 1. PS1 at index 1. Okay? The last iteration, we're going to get also PS2 at index, but now 2. Also PS1 at index 2. Right? So these are the 3 variable assignments that will be executed between the iterations. Okay? Okay with this? Well, at least you know what's going to be executed, right? So I would say you can definitely choose to say maybe for every iteration, I'm going to update the diagram right away. But for me, I just kind of prefer to write down exactly what's going to be executed, right? So it's kind of completely up to you. Okay, let's now try to trace it. So for this one here, let me just use a different color here. Okay, let's say for iteration number 1. Okay, this is saying we're going to copy the address that is stored in PS1 at index 0. PS1 at index 0 is storing the address of this object here. We're going to copy this address into PS2 at index 0. PS2 at index 0. What does that mean? That means rather than pointing to null, it's going to point to just the same objects that PS1 at index 0 is pointing to. Okay? So for that one there, rather than pointing to null, it's going to point to just the same objects right here. Okay, let's do one more time. Okay, I'll repeat the same thing, but in a different scenario. So what about iteration number 2? Right? So here we're saying copy the value that's stored at index 1 of PS1. PS1 at index 1 store the address of this particular object. And we're going to store the address of this object into PS2 at index 1. So PS2 at index 1 is here. After the assignments, we're going to let it, rather than storing now, it's going to point to just the same objects right here. Okay? Rather than pointing to null, it is going to point to right here. Okay, the final bit. And if you somehow got exactly what's going to happen in the first iterations, the third one should be quite straightforward. Okay? So PS1, 2. PS1, 2 is pointing to here. We want to change PS2, 2. PS2, 2. So it's going to point to, rather than now, pointing to just this object here. Okay. Rather than now, it is going to point to right here. All right, any questions? So basically, after executing the entire loop, we're going to get somehow PS1 and PS2. Index-wise, they pointed to the same objects. So we really have create aliasing. Okay? Aliasing in the sense that we'll do another exercise in a separate page. For example, for this object here, for Mark, there are 1, 2, and 3 arrows pointing to the same objects. Either just the mark reference over here, will PS1, 1, or PS2, 1, also point to this object. You can try to access the same objects in either of the three expressions. So that's aliasing. You got three aliases or three names that can refer to the same objects. Okay, so that one there we'll do another exercise soon. Yeah, question?
So, in the second array, persons 2, let's say I were to do persons 2 index 1 dot set name and I changed his name to Marcus or something. Would that affect, like...
It will. I see what you mean. Hypothetically, let's say we say PS2 at index 1, and then we say set the name. So that means we are changing the name, let's say from Mark into, let's say, Jonathan. So you can see that the same object here is also being referred to by this location here and also this location here. So now after the change, if you try PS1 at index 1, dot name is going to be Jonathan. Also, if you try mark.name, it's also going to be Jonathan, right? Good. So that's a very common, these are very certain phenomenon for aliasing. Aliasing simply means if you try to access the same object using just one of the aliases, the effect is going to be visible to all the other aliases for the same objects. Okay? We're going to see something very similar actually in the following code. Okay, let's now move on. So let's now say we go for this line. Okay, the next line. So we say persons 1 at index 0. Persons 1 at index 0 is going to refer to this object here. And set the age to be 70. Set the age to be 70. Right away, if I try Alan.age, it is 70 because they are aliases. Okay? So let's try out these values right here. Okay? So what will be Jim.getAge right here? 0, yeah, thank you. So Jim.getAge is going to be 0 right here, right? So just not to pollute the diagram too much, that'll be 0. And also Alan.getAge, Alan.getAge 70, right? So it's been changed, okay? And then if I try persons 2 as 0, and then getAge is kind of one of the aliases. So if you try the .age, it's going to be 70 as well, okay? So far, the lesson I really want you to learn is you want to be very smooth and proficient and very precise about tracing the code by drawing diagram. Because the print line or any assertion might occur anywhere in the middle of the code. Up to that point, you want to know exactly what the state is for all the objects and their attribute values. So you will be able to answer the question precisely. Right? So you really want to be sure you're able to trace. Okay? And then we got more changes. Let's say we got this one here, okay? What we are saying is we're copying the address that is stored in Jim, which will be the address for this object here. Copy the address of this object into persons 1 at index 0. Notice that here, we're only modifying what is stored at index 0 of persons 1. So persons 1 at index 0. Currently, it is pointing to here, right? It's not going to point there anymore. It's going to point to wherever Jin is pointing to. So it's going to point something like this. All right? So what's going to happen is, rather than pointing to over here, it is going to point to Jin. Let me repeat one more time, okay? The way to understand this line here, we are trying to copy the address that is stored in Jim. Jim stored the address of this object here. Okay? And then we want to copy this address into persons 1 at index 0. Persons 1 at index 0 used to be pointing to Alan objects, but now it's not going to point there anymore. It's going to point to just the same objects that Jim is pointing to. That's what I just changed. Okay? And the next one. If I try persons 1 at index 0, right? Notice that persons 1 at index 0 is already being redirected to the Jim objects. So if I say set age, I'm actually setting the age right here, not Alan object anymore. All right? So here, so if I follow persons 1 and index 0, persons 1 index 0 is really pointing to this object here for Jim. Modify its age to be 75. Okay, so this value here is going to be 75. So after these two changes, we are basically going to ask the same 3 questions about print line. The values may not be the same since we have done some changes, right? So that's why you got to be very careful about tracing each line precisely. Let's see line by line. So now, if I say Jim.get age, right? Go to Jim, age will be 75, right? It's been modified. And if I go for Alan.get age, 70, right? So, okay, Alan.age will be 70, remain the same, which is okay. And persons 2 at index 0, persons 2 at index 0 is still referring to this Alan object. So the age will still be 70, right? Of course, I might ask you a different expression, but I'm just giving you some example, okay? All right, so that's the complete tracing about answering this question here. So what you really want to do, once I release the recording, I would suggest, if you're still kind of not exactly following the process, rewatch the recording just for this part, make sure you're really completely comfortable with what's really going on here. And then, second step is the most important. You want to practice tracing like this. I guarantee you'll be given something at least as complicated like this in your written test. So please get ready, early. And try this example here. If you got any trouble just understanding it, you can always come back to me. Okay. Before I leave the example, any questions? I'll take one by one. Go ahead first.
Quick question. For persons 1, persons 2,
yeah.
You know how you wrote like index 2, right?
Yeah.
To access like the name Tom in person 1. So if instead of using index 2, could you use index minus 1?
Index minus 1. That's interesting. Okay. So you're asking, can I say something like, okay, sorry. Can I? Mm-hmm. You mean like a PS2, let's say index minus 1?
Yeah, or like PS1 index.
Okay, the short answer is no, you cannot say minus 1. Because when you pass an index for the array, the minimum index you can ever pass will be 0. Minus 1 is going to give you array index out of bound exception. Okay, maybe that kind of answers your question, right? Okay, so I can write it down just in case, right? So whenever you want to access some array, if you say array indexing, let's say I here, right? Let's say A is an array. Let's say we assume A is not, okay. In order for this expression to work, number 1, A cannot be null. Otherwise, you got null pointer exception, right? Number 2, I should be within certain range. 0 should be the minimum, always, okay? 0 should be less than or equal to I. Now, less than or equal to what? What will be the maximum index? I rate that length, minus 1. Minus 1, right? Okay. Okay, that's the important conditions for you to know, right? So for example, if you got an array, for example, let's say I got 0 here, and then I got all the way to 9, right? If I tell you this, what's the length of the array? 10. Should be the maximum index plus 1, okay? For example, if the array like this, that tells me A.length should be equal to just 10. Conversely, if I tell you that the length of the array is 10, what will be the maximum index? Should be the length minus 1, right? Just in case you kind of forgot about this detail, make sure you be aware. Okay. Let me do another thing here. 2 things I would like to do, okay, before we take a break. Okay. The next one here, I want to show to you just something also very interesting about aliasing. So here you can see what we are copying here is about individual elements. For example, I say, whatever that is stored in index 0 here, I'm going to copy the address into index 0 at element level. I'll show you something even more efficient. I'm trying to copy addresses of array as opposed to array elements. And then I'll make some remark afterwards to see which approach you should really choose. I'll talk about it in a moment. But let's go through the exercise. All right. We'll build this up, from scratch, so you'll see exactly what to be expected. So we are talking about copying arrays. Okay, let's say we still got PS1, PS2, storing person. So what I have is I got person, array, and then I got PS1. But this time I say semicolon right here. I only declare that. And then I got person, array, another one, let me call it PS2. Also semicolon. And then you can imagine that if I write this one in Eclipse, let's say, and then I put a breakpoint right after the execution of these two lines. So let me say that's breakpoint number 1, right? So right after these two lines, execution. Now I want to somehow evaluate several Boolean expressions to see whether or not it's true or false. Okay, let's now discuss this. So I'm going to draw some table aside right here. Oh, actually, that, okay. So we got 3 expressions to evaluate. Okay, I'll put down one by one. So the first one is the PS1 equals null. And then PS2 equals null. And then PS1 equals PS2. Right? So these are the 3 expressions I would like to evaluate one by one. So let's now just, we don't need to use the Eclipse just yet. Let's just try to trace and answer these questions. At breakpoint number 1, meaning that we have already executed these 2 lines, just declare, right, these 2. How do we visualize them? PS1 and PS2? At this point, have we created any array object just yet? We haven't. Good. Okay, that's a good sign if that's what you're thinking. Now, in that case, PS1 and PS2, they haven't stored any meaningful address just yet. It'll be just null. Okay? So what we got is, we got PS1. You can think about just pointing to null. And also PS2, also pointing to null. Okay? Now, given this, we can answer these 3 questions. PS1 equals null? True. PS2 equals null? True. Are they equal? They are. Null equal to null. Okay. Not exactly aliasing, but just kind of funny scenario. But that's something we ought to know too. Okay. So we got true, true, and also true. All right. It's a good beginning stage to be aware. Okay. Let's now build up further. Let's say I try to initialize PS1 to be some certain array. I'll just say new, for example, right? And I'll just omit the detail, some array. And also, I also got PS2 is some new array. And here you can even assume maybe I also try to maybe initialize the contents of the array by certain elements. But it doesn't matter. That's not the point. I want to focus on just on the array address level. So let's call this one here number 2. So breakpoint number 2 is at the point that I have executed all these 4 lines. Okay? So how do we visualize this then? So basically we got, so PS1, rather than pointing to null, is going to point to some new array right here. And the length of the array doesn't really matter, just some array. And PS2 is going to be just another new array, just different. So PS2 is going to be just pointing to another array. Right here. Okay, PS1 and PS2. Okay, let's now answer. After, okay, at the breakpoint number 2, PS1 equals null, false. It's really pointing to something. Similarly, PS2 equals null, also false. Now, PS1 equals PS2, false, because they're different array objects, because 2 different new keywords, right? So we got false, false, and false. Okay, all good. Let's now take a look at something interesting. Now, let's say I want to make PS2 having the same contents as PS1. What I did earlier was I created PS2 separately and then gradually copy over the contents of PS1 into PS2. That's one way to do. But now I can show you another more efficient way. Not necessarily better, but just more efficient. Okay? A single line. Okay? So I can simply write PS2 assign PS1. And then let's now talk, let's name this one here, okay, this is number 3. Yeah. I'll talk about it, yeah, bear with me, okay? Yeah, so number 3 here. So what we're doing here is really, we're trying to create alias at the array level, okay? Creating alias at the array level. So what we're doing is this. PS1 is pointing to the beginning of some array. You can think about PS1 store the beginning address of some array objects. PS2 also stores the address of some beginning the address of the beginning of some array. So now I'm copying the beginning of some array that's stored in PS1. Copy that into PS2. What does that mean? That means PS2, rather than pointing to the beginning of this particular array, is now going to point to the same array that PS1 is pointing to. So we are really following the same pattern about address copying, but just that, rather than at the element level, but we are doing at the array level. Okay, I'll repeat one more time. We're basically copying whatever that's stored in PS1. PS1 stored the beginning address of this particular array. We want to copy the beginning address of this array into PS2. So that means PS2, rather than pointing to here, is going to point to just the same array like a PS1 is pointing to. That's what we're doing, okay? So what that does is PS1, rather than pointing to here, rather than that, is going to point to right here. All right? This is actually very important to understand, right? We are copying address. And of course, you want to be very careful. In the test, I might either say PS1 equals PS2 equals PS1. I might also swap the order. In that case, you got to change the arrow in a different way. Question?
So what happened to the previous array? Like, do we discard?
Okay, good question here. Okay, the question was, let's say after this assignment here, apparently this array here, let's say at the moment, let's assume these are the only 2 variables. So apparently this array object is not being pointed to by any, its address is not being stored in any array variable, right? So I would say this part, this time here, this will be a very good candidate for the automatic garbage collection by Java, okay? Luckily, we have no control over about the garbage collection, about freeing the memory, so we don't have to worry. But you can kind of assume that any memory that has been freed up from our code, it will be automatically handled. But of course, if you program in a language like a C, then you have to maybe deallocate the memory. But that's not our concern in this course.
So every time you make like a new person, like with assign to like something new, it makes like a new whatever that is. Or something?
Yeah, of course. Every time you use the new keyword, that means you want to allocate some new block of memory. Yes. Mm-hmm. And anytime if some block of memory somehow is not being used anymore, you can assume somehow at some point it will be garbage collected, but it's not within your control. Mm-hmm. Okay, good. All right, let's do a final one. Oh, sorry. So let's actually fill in the table. So after breakpoint number 3, okay, after this, right? So now you can see at this point PS1 and PS2, they are both not null. And they point to the same objects. So this will be false, false. They point to the same object, so this will be true. All right? So false, false, and this will be true. They point to the same objects. Okay, a final one. Okay, just for information. Let's say I somehow want to do PS1 is assigned to null. That simply means PS1, rather than storing the address of this particular array, I wanted to store just null. That's what I'm saying. So what I'm doing is PS1, let me use this color here, okay? Number 4. So PS1, rather than storing the beginning address of this particular array, is just going to store just null. That's what it is doing, all right? So now let's do the final comparison here. So now PS1 equals null, true. PS2 was not changed. It is still storing the address of this particular array. So it's not null. And then PS1 and PS2, one is pointing to null, the other one is pointing to something that's not null. They are not equal. All right? So here's a question. This line here is basically making PS2 and PS1 the same array. So PS2 at index 0 will be equal to PS1 at index 0, and etc. They have the same contents basically, but they're basically the same objects, right? On the other hand, this one here, PS2 and PS1 after the for loop, what we got is there's individual different array, but somehow index 0 and index 0 point to the same object, index 1 and index 1 point to the same object, right? So which one should you choose? The answer is, it depends on what you need. You want to think, well, to your particular application, if you really want PS1 and PS2 to be separate array objects, like a separate memory block, in that case, you definitely should really choose this one here. But if you really don't mind, if they're to save the memory space, you just simply want PS2 and PS1, just store the same address of the same array. And without worrying about aliasing, in that case, you can choose option number 2. Okay? So it's really no right or wrong choosing which one. I want to show you both. Okay? So when you do your labs, whenever you want to copy maybe contents of the array, you can somehow consider maybe this one here. However, watch out. If you do this approach over here by doing this, that means whenever you change anything using the PS2, let's say PS2 at index 0, if you modify this particular index 0 element, it's going to be reflected to PS1 at index 0 as well. If you are okay with that kind of aliasing effects, then go ahead with it. If you don't think that's acceptable, then you shouldn't go for this particular copy. Right? So that's a rough guidance for you. Okay, one more thing very quickly, and then we'll take a short break. Okay, one more thing. So I want to summarize this exercise here just by talking about just aliasing path, really. Okay, so let's say we choose this object here, right? So let's say we identify this particular object in the memory. Okay, so this is the object that has the name Alan and has the age 0. Okay, so this is basically after we execute the for loop. Okay, so I'm just showing a snapshot of that. So the question is, I want you to list all the alias path to Alan. Basically, all the expression that store the address of this particular objects. Okay, first of all, how many are there? According to the diagram. 3, okay. How did you tell?
Well, you can use like Alan, lowercase a-l-a-n.
Oh, no, how did you tell it's actually 3?
Oh, like I just counted like the different aliases.
Okay, aliases. Okay, maybe that's exactly what you mean, but let me just make it more explicit. To really see how many, look at the object diagram here and then see how many incoming arrows you have. 1, 2, and 3. If you got 3, that means you got 3 different paths. Okay? So look at them one by one. The first path is right here. So that one corresponds to just Alan. And the second one is this particular arrow. And that one there corresponds to persons 1 at index 0, right here. And the third one is the arrow from here, right? And the arrow is persons 2 at index 0. Right? 1, 2, and 3. Okay, just look at how many incoming arrows there are. Okay. All right, any question about this? Okay, if you're good, we can take a short break by taking attendance. All right, so let's now change to a new topic. I want to talk about static variables. Okay, so today I was just going to talk about some motivating example about why we should really use something that static variable can provide, which is about global storage. That's something we'll talk about. And then we'll talk about maybe once you put the static and non-static variables in the same class, how are you supposed to separate them when you do the tracing? Okay, these are the 2 things. So if you look at the slides, it's going to be starting from slide number 75. Okay, let me just go there quickly. Okay, static variables. Okay, so the motivating example here is just about some class called account. Okay, So let's go over the account class and then get some idea. Okay, so let's just go from there, and then we'll see why, without using whatever we have learned so far, is not sufficient. Okay, let's see. So let's say we have an account class right here, and then we have ID. You can think about ID as like a unique ID that we can use to identify each account, right? Each account should really have a different ID. For now, for simplicity, just an integer, okay? And then the owner, which maybe the name of the owner, and then we can have an accessor to return the ID, and then we got a constructor, okay? So this version here of the account shows that this ID parameter, you can see we got variable shadowing. You can see ID here and ID over here, right? Whenever you're creating a new account object, you want to initialize the ID right away. That's what we want to do. Okay, so let's make a note right here. Right, so we got integer ID. So this is some explicit parameter. Okay, so it's an explicit parameter, and this is something that whenever you want to use the account class by calling this constructor, you have to make sure the argument ID should be an integer that has not been used so far. For example, 1, 2, 3, 4, 5, etc. Right? There should be no duplicates. So this parameter value presumably should not clash with any existing IDs. Presumably should not clash with the existing IDs. Right, so just notice that in this, the design of this method here, we have to use a parameter right here. But we're going to see why it is bad. Okay? So to really see its drawback, let's see how we actually use the constructor. Let's say in this class over here, let's say the tester. So we are trying to create new account objects, 2 of them, right, separate. Okay. So here you can see we got the ID arguments, 1 and 2. In this particular test case, you can see 1 and 2, they are different values. They're unique. There's no duplicates. This is good. However, you can kind of see right away, for me to really use to create the account objects, I got to make sure the numbers I use over here do not really repeat themselves. Imagine that if I actually have to create maybe 1,000 account objects, maybe at different timings, I always have to go back to see what numbers I've really used. And also numbers over here do not necessarily have to be continuous. Maybe sometimes I use 50, I use 23, etc. I got to make sure every time I use a new number for the new account, it does not clash. Question?
Sorry, what is the text say there, the magenta text?
Which one? This one here?
Yeah.
Presumably.
Just all of it.
Presumably should not clash with existing IDs. So here, let's say, so this will definitely be the burden. So it's really the burden of the user. Burden on the account user to specify unique ID. Unique IDs. Okay, it's really a burden. So let's say something goes wrong. Somehow, if I specify here rather than just 2, I simply put 1. So we have created 2 account objects with the same ID, which is not good, right? So 2 accounts should always have different IDs. But let's say if I do this one here. Now, am I going to get any error from the compiler? How come? Yeah, just about because type-wise, there's no type error really, right? But this is more like a logical error, right? Good? Okay, that's exactly what I want to say. But I think you guys pretty much got it, right? So this one here is not going to give me compilation error because 1 here, simply integer, nothing wrong. Okay, good? Okay, let me write it down. So number 2 is when IDs are duplicated, it is not a compilation error. Instead, it is a logical error, which means you will not realize about this error until you actually do some thorough testing to find it out, which is going to be more costly. The earlier you can find out some error, the better. Okay. So this example here, just very simply try to illustrate to you, if you try to use just normal attributes over here for ID, you cannot get around. You have to pass the ID right here as part of the constructor. But it's going to be too manual for the management. You got to make sure you keep supplying unique IDs. So what we really want to achieve is as follows. So the goal will be, we want to automatically generate and manage the IDs. So that's our goal. And the auto here is very important. That means we don't really expect any user to really pass manually the IDs one by one. Somehow in our program, in our programs for the account, we will be able to do some syntactic difference. So we can actually achieve that. But that's something we're going to learn. Right? Any question? That's more like a motivating scenario, why we want to use something like this, right? So to really achieve this goal, we need something that can be global and shared among all the account objects. And to really do that, we need a keyword called static, all right? Maybe you have seen that in the first year. If not, now it will be the time to learn. Okay, I'll show you from scratch. So we got about 18 minutes. I think that's enough time. I want to go over with you about the basic usages of the static variable. Okay, that's enough for your review and also for the test. Also, I can show to you on the lecture site. Okay, so you will see that under the codes right here, you will see that I also put static versus non-static variable right here. Okay, you can also download the source code, import it to your Eclipse, and also play with it. I didn't really give you the code about the account class. That's something you can also reproduce yourself on Eclipse rather easily. Right? All right, let's now take a look. So there are two classes over here, and then I'm going to go over in detail. Okay. So we have a class called counter, just for illustrate, not account at the moment, right? We'll resume the discussion about account on Tuesday, but for now, just a counter. Okay, and also got some counter tester. All right, the counter class. Right, you can disregard this one just for now. Okay, we got two variables here. We got L standing for local. We got G standing for global. Okay, we got two variables here. And notice that the static keyword is only declared with G, but there is no static keyword with L, right? So this makes this one here the so-called non-static variable or attributes. And this will make this one so-called a static or global attributes. Not attributes, sorry. These will be the static or global variable. Let me write it down. Let me start with the int L right here. So this one here is the so-called non-static variable. Or we simply call them attributes. Okay, that's the first one. Okay, and then we also got the static, the second one, static int G. Think about decoration that we learned earlier. You should add static to the left. You cannot say int static G. It's not going to work, right? You got to say static first, and then the type, and then the name. And this one is so-called the static variable or global. The static variable. I'll mention the word global in a separate context, okay? And let's take a look at right away how we actually initialize these two variables. So there are certain conventions that usually Java programmers will follow. So let's look at something we already know. So you can see for this attribute over here, we only try to initialize it in the constructor, okay? Non-static variable initialized in the constructor. It's not syntactically wrong if you simply say L equals something, but it's not the normal way to go. You should really try to only initialize a non-static variable or attributes in the constructor. Okay, that's number one. On the other hand, number two, the static variable, which is going to be global, you want to initialize that to be some value right away when you declare that. Okay, so this one says static variable initialized as soon as it is declared. Right, so syntactically, you want to know the difference, right? So for non-static, try to initialize it in the constructor. For static, try to initialize it as soon as you're declaring it. That will be the convention. Okay? Let's dive a little bit more deeper into what exactly it really means when we have non-static versus static. Okay. So let's first of all talk about the non-static. Okay, this one here. Non-static simply means each counter object in this case is going to have its own copy of the local variable. Okay, just one copy for each object. So each counter object has its own copy. So we said that it's going to be the instance-specific value for that particular copy, right? The L value can be 1 for one object and can be 3 for another object. Instance-specific. Value. Okay, local. On the other hand, let's now take a look at static. Okay, I'll put star, 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 star over here. It's kind of the opposite. So there's only a unique copy of the global variable, and that unique copy is shared by all the counter objects. So all counter objects share a single or unique copy. Right? So that's why we say it's a global variable, just global. Everyone can see it. I mean, every counter object can see it. Global variable. Right? Any question about the distinction between non-static and static? Okay. And then let's see how we can actually modify them, in different methods. So here we got some accessor here. Just get a local. Easy, just this.l, right? Okay, you can see we're using the this for the context object. And also we can say local variable this.l plus plus, right? Increment local. So these two are very straightforward. But let's look at this one here. So this method here, we are trying to modify the global variable. Okay? You might be wondering, can we say this.g plus plus? All right, so let me put it down first. By the way, so this method here, the intention is clear. We just want to increment the global variable, the single copy, just by 1. However, the question now is, can we write? Okay, so over here, if we write this dot g plus plus, is it going to work? This is still going to work, and there is no compilation error. However, there will be a so-called compilation warning. A warning is more like a yellow underline as opposed to red underline. Okay? Warning is actually okay. It's not going to cause any deduction of your marks in the test or the exam. However, you ought to know why having this.g is conceptually unacceptable. All right? So let's see why. Shortly speaking, when you say this.g, so this over here should be replaced by some counter objects, for example, like a c1.g. But to really use a static variable, you don't really need to use a context object because somehow the global variable belongs to every object. So you don't really need to use a particular object to access it. So the right syntax to access the static variable is to use a class name as opposed to individual context objects. So already there. So when you talk about accessing static variables, the syntax will be, you want to say class name, and then dot, name of the static variable, name of the static variable. And example, in our case, we can simply say counter the name of the class and also G, the name of the static variable. So we can say counter dot G. So this will be sufficient, right? So if you actually want to replace the counter by some context object, it will still work, but it's just a warning. All right, so I would say try to avoid as much as you can. You don't even want a warning. So this one here, let me write it down. So this will compile, but with a warning. All right, so that's about the syntax and also usage about non-static and static variable. Let's now try to trace this fragment of code, right, to see what happened. Okay, so this will nicely illustrate to you about when you want to kind of use both the static and non-static variable, how they should be visualized. You can see the beginning of this code here. We are trying to create the first and second counter objects. So at this point, you want to scan through the class you're tracing right away. If there's any static or global variable, you may want to initialize them right away and visualize them as well before you start creating any objects. Okay, so I'm going to put it here. So I would say this is even just your step number 0, some initial step. So step number 0, I'm going to put it here. You basically just want to set aside some location in the memory. Okay, so I'm going to write it down here. Some location in the memory, and here it's not really an object, it's just like some memory location. And I say this memory location is really just for a counter. Just counter like that, okay? And then I can say G here, that's the static variable right here. But you can put a star if you want to, or put any symbol just to indicate it's really not, it's just a static variable. It's not really non-static, right? So if you like, so you can think about this is like a static, right? And then the initial value right here should be 0, right? Put 0 here. So this one should be done even before you start creating objects, because once you start creating objects and calling methods, this location here, that's global, might be modified already. So you want to make sure you kind of get it ready, right? And then we'll try to create 2 counter objects, right? Counter object number 1, that'll be C1. So we got C1 stores the address of a counter object right here. And this will be the object box. Now, how many attributes should we include in the box? In this case? Just local, right? Good. You should really include non-static attributes only. You don't really include in the individual objects box any static one. Static one should only be set aside with a unique copy. So in this case, the only non-static attribute we have is L, local. That's the only one. Okay? So we put L here, and then this constructor here simply keep the default value 0, or explicitly assign 0. So put 0 here. All right, and then we do the second one. The second one is right here, C2. So C2 stores the address of another counter object. C2 stores the address of another counter object right here. And then also L. So now you can see that this point, each counter object has its own copy right here. And all the objects, they share the same copy of the global. Right? That's exactly the 2 points I just made. All right, let's now try to trace. Okay? So if I do, let's say this one here, C1.getLocal, right? So if I call the getLocal here, replace this by C1. So C1.local will be 0. And if I say C2.getLocal, right? So calling this method again, so replace this by C2, right? So C2.getLocal also is 0 at this point. Haven't been changed just yet. Okay? The correct way to accessing the global is here. If I say counter.g right here, I'm saying go to the global variable that's associated with counter that's called g, right? This will be 0. If you simply try, let's say, c1.g and also c2.g, that's also fine. You will still get 0. You're still accessing the copy, but you will get some warning about you should really use a class name rather than context object for accessing the static variable. Okay, that's something you can keep in mind. So we got 0 and 0 over here. All right, let's now do some changes to see what's going to happen. Okay, so if let me call that maybe 1, 2, 3, and 4, and then 5. We got 5 changes in total. Okay, let's see what's going to happen. Start with number 1. C1.increment local. So increment local right here. So the context object is C1. So we got C1. C1.l, C1.l incremented from 0 to 1. That's what it does, right? So this is 1. Okay, and then we're going to get C2.increment local. So increment local, but this will be C2. So C2.l plus plus. C2.l plus plus from 0 to 1. So this is what change number 2 did. Okay, and then we got C1.increment local, we got C1 and C2.increment global. Right? We can still do it. Let's see. So here we retry C1.increment global. So increment global here, it will simply just increment g, basically, right? So after this one here, it will just go from 0 to 1. So this is after number 3. Okay? And then if we try this one here, again, C2.increment global, so executing this one here, so incrementing g once more, so they'll be from 1 to 2. So this will be number 4. Okay, finally, if I try, let's say, counter.g assigned to counter.g plus 1. That will be the more recommended usage. Just use a class name, the static variable. In that way, we're going to increment it from 2 to 3. And this is number 5. All right? So these are really the basic usages about using static versus non-static variable and also how to trace them. Okay? Any questions about this? Yeah, take one by one. Go ahead, please.
So if you put like this.g
Uh-huh.
and run it, and then you use C1.increment global and C2.increment global, does it still only increment the global value? Or does
It will only, yeah. So you're basically saying, for this one here, if I say this.g plus plus, okay? So now if I call C1.increment global, of course, this will be replaced by C1. So C1.g. C1.g is still referring to the only copy here. It's just that you will get some warning from the compiler to say you should have used just a counter class as opposed to context object. You will still do what you really intend to do, but it's not recommended. Okay. All right, guys, I got about 1.5 minutes. Okay, I want to do just one more thing, okay? So we have already covered static versus non-static. So what you should really do is go ahead and study the OOP review slides. There's still a few topics I haven't really covered just yet. I'll do that on Monday. I'll make sure I finish them, but don't wait for me because your programming test 0 is next Wednesday. All right? So I want to say one more thing. Okay, bear with me. So after this, I want you to look at slide number 76 as well. So this will be the ultimate solution. We want to automatically generate and manage the ID. So notice that over here, we got both the static variable and also the non-static attributes. So look at how these two are being used together and also see how the ultimate solution can be understood. We'll talk about this next Tuesday. All right.